Hello everyone and welcome back to our channel. This is another video in our Euclidean geometry playlist, and we're going to be talking on congruency in this video and similarity. So let's go straight into it. We are going to start off by defining the term congruency. So what does it mean when two triangles are congruent? Two triangles are congruent if one fits exactly over the other. This means the triangles have equal corresponding sides and angles. So two triangles are congruent if one fits exactly over the other. That means they're exactly the same. If they're exactly the same, then they're congruent to each other. To determine whether two triangles are congruent, it is not necessary to check every side and every angle. We indicate congruency using three horizontal lines like this on top of each other for congruency. So congruent in symbol form will be three lines on top of each other horizontally. So we have four conditions in which we can prove two triangles are congruent to each other. So let's have a look at our first one. So the 90 degrees hypotenuse side. This is how it would look. And it always has to have a 90-degree angle because we're talking of the 90-degree hypotenuse side. So if the hypotenuse, I'm going to use the highlighter for you guys to see properly. If the hypotenuse and one side of a right angle triangle, so it has a 90 degree, that means it's a right angle triangle, are equal to the hypotenuse. So let me use another color. So if these are equal to the hypotenuse and the corresponding side of the other right angle triangle, so it's a right angle triangle because it is 90 degree, then the two triangles are congruent. And our reason would be right hand hypotenuse side, so right angled hypotenuse side. So if we were to write that these two triangles are congruent to each other, let's do that for practice sake. So we're going to have triangle ABC, triangle JIH. So whenever you write congruency, make sure the corresponding side is in the same position as the other corresponding side in the other triangle. So this is how you'd write it. So triangle, the symbol for triangle, let's pretend that's a triangle, or let's just do that. Triangle ABC is congruent to triangle. Can you see we said ABC? That means here we also have to start with the angle that corresponds with A, which is J. So J, I, and H. The H has the 90 degrees, the C has the 90 degrees. So it always has to correspond. So let's see, we have to say triangle because it's a triangle. That's the symbol for triangle if you don't remember. And if they're congruent, then it's three lines on top of each other horizontally. That means triangle ABC is congruent to triangle JIH. Let's have a look at the second condition, which is the side. So, if three sides of a triangle are equal in length to corresponding sides of another triangle, then those two triangles are congruent. So if you can prove that in this triangle, this side here and this side are equal, not equal to themselves, but if this side is equal to that side and this side is equal to that side of the other triangle and this side is also equals to that side of the triangle, then you can surely say that this triangle is congruent to that triangle. So if you write it in words, that would be P. So let's label our graph first, or our figures. PQR and STU. And if we were to write that those triangles are congruent, we'd say triangle PQR, and if you can see, the P is right there, so PQR, and if we say PQR, we have to say STU. So is congruent, the congruent sign is congruent to triangle STU. And that's how, so if you can prove that there is a corresponding side in triangle QR and in TU that are equal, QP and TS are equal, and PR and SU are equal. And as you can see, those are three sides. That's why our condition is side, side, side. So let's have a look at our third condition, which is the side angled side. So this is how it would look. So if we're to label our graph F, G, H, or triangle, and this one I, J, K, then they will be congruent if and only if two sides, and so two sides, which is FH and GH, and the included angle of a triangle are equal to the corresponding, so in the other triangle, corresponding two sides, so this side and that side, and the included angle of another triangle, then the two triangles are congruent to each other. So that's another case, side angle side. And notice the angle in this case always has to be included, so always has to be in the middle of the two sides that are correspondingly equal. Let's have a look at our fourth condition. So that's the angle side. If one side, so this is how it would look. So let me just draw it so that it's easier to understand. So if we were to label this graph U, V, W, and were to label the other graph X, Y, and Z, then if one triangle, so we're looking at UVW, and two angles, so if one side, which is VW in this case, and two angles of a triangle, which is V and U, are equal to the corresponding one side and two angles of another triangle, then the two triangles are congruent. So it's in this case, if you have two triangles and there's a corresponding angle for U as in X, and a corresponding angle for V as in Y, and a corresponding side as in VW, which is also in this case YZ and VW are equal, then we are to say, because of angle side, that's the reason or the rule, then they are congruent to each other. And note that the order of letters when labeling congruent triangles is very important. You cannot say triangle UVW is congruent to triangle Y, Z, and X. It just does not work like that. Because if you can have a look, U is right there. You are saying U is corresponding to Y, and that's not the case, because U has one line on its angle and Y has two lines on its angle. And you're saying V is corresponding to Z. V and Z are not the same angles, or they're not equal to each other, and W and X are also not the same with each other. So you have to label it in such a way that you're saying the first letter of the triangle is corresponding with the first letter of the other triangle. So if you were to say UVW, so triangle UVW is congruent to triangle XYZ. So XYZ. Why do we say so? Because U, look at the angle U and look at the angle X. So U and X, let me underline that for you to see. So can you look at angle U and look at angle X? They are corresponding, right? Angle U and angle X. They both have one red line. Angle V is equals to angle Y, because that's true because it has two lines and Y also has two lines, meaning they're equal to each other. And W is equals to Z because W has nothing on it and Z also has nothing on it, meaning they're equal to each other. So this is how you prove for congruency in triangles. Now let's have a look at, so I've just discussed this right now. Order of letters when labeling congruent triangles is very important. And so that's what I was explaining in the previous slide. So we're going to discuss similarity now. Now let's start off by defining the term similarity, or what does it mean when two triangles are similar to each other. Two triangles are similar if one triangle is a scaled version of the other. This means that their corresponding angles are equal in measure and the ratio of their corresponding sides are in proportion. The two triangles have the same shape but different scales. Congruent triangles are similar triangles, but not all similar triangles are congruent. We use the vertical lines, three vertical lines together to indicate that two triangles are similar to each other. So what does it mean when we say two triangles are similar if one triangle is a scaled version of the other? This means if we have a triangle ABC and this side is 1, this side is also maybe 1, and this side is 5 maybe. So this side is 5. Then if we're talking about this angle or this triangle and we're saying it's a scaled version, and we say that this is now 2.5, so this side is 2.5, this side is a half, this side is also a half. We know that this angle, and that angle are equal to each other. We can see that that triangle is a scaled version of that triangle, meaning that this triangle is half the size of that triangle. That means it's similar because there is a certain scale that we are using to get this triangle over here. So we are basically dividing each side by 2 and we get 2.5. We divide 1 by 2, we get a half. We divide 1 by 2 and we get a half. So it means two triangles are similar and one triangle is a scaled version of the other. So now let's look at the two conditions that make two triangles similar to each other. So our first version is the AAA, which is the angle. So if you have two triangles and their angles are the same or are corresponding, let's have a look at this to better understand this angle condition. So let's say there's A here, B and C, and there's also A here, B and C, but the triangles are different. So this one is A, B and C, this one is I, H and J. We can see that in triangle ABC and triangle IHJ, triangle or angle I is equals to angle B. So let's mark it with the same color. Angle A is equals to angle H. So let's do that. And angle C is equals to angle J. So let's do that. And we can see that all the sides are equal. So there's an equal side for each triangle, meaning if we're looking at this B, there's an equal side for B, which is that B on the other triangle. So that means it's angle. And if all three angles of corresponding angles of two triangles are equal, then the triangles are similar. So if you have two triangles and even though they don't look like the same shape, they don't look like the same size, but all their angles look corresponding, like when you look at this side of the triangle, or when you look at one triangle, there's a 35 degrees, and when you look at the other triangle, there's a 35 degrees. When you look at that triangle, there's 90 degrees. When you look at that triangle, there's a certain degrees that's equal to each other. Then we say those triangles are similar, and it makes sense. They're similar, but they're not congruent. They're not exactly the same, but they're similar because they have the same angles. So let's have a look at our second condition. And in similarity, we only have two conditions. So the other condition is side, side, side. So if you have a triangle and you have two triangles and they have corresponding sides that are equal, then you are free to assume that they are similar. So if all pairs of corresponding sides of two triangles are in proportion, then the triangles are similar, not equal but in proportion. So let's have a look at what they mean by that, or what we mean by that. M and L, R S T, sorry about that, R S T. Then we have that if we say they are similar, then we have their proportions being similar also. So MN, which is this side, MN over RS. Then we have is equals to, so all that is equals to ML over RT, and all that is equals to NL over ST. And let's have a closer look at this. Maybe let's make it bold. We can see that we mean make it more visible. RT and L ST. We can see that MN, so MN, which is this side, is corresponding to RS. So MN is corresponding to RS. And we can also see ML, so ML is corresponding to RT. We can also see that NL is corresponding to ST. And so that's what they mean by if all three pairs of corresponding sides of two triangles are in proportion, then the triangles are similar. The order of letters for similar triangles is very important. Always label similar triangles in corresponding order. So both similar and congruent triangles in corresponding order, as I explained in the previous slides. So thank you guys for watching. See you in our next video as we discuss the theorem of Pythagoras and we try to solve problems using the knowledge we have gained so far from the videos I have produced. Thank you guys for watching. See you in our next video. Bye.